This is Dr. Bruno Gobato. I am a shoulder and elbow specialist. I live in Brazil. I work with 3D printing and 3D planning since 4 years ago. I use mainly open source softwares. So in this we're going to show how we can 3D plan any surgery, any orthopedic surgery where we are using a shoulder surgery. This is a patient who has more than 10 times dislocated his shoulder. He's a very young patient and he has a bone bunkered lesion and a Hill-Sachs lesion. I'm going to show you here first his 3D prints. Let's zoom a little bit here so you can first understand what we are doing. So here is the glenoid of the patient. You can see that he has a bunkered lesion right here. As you can see here, his glenoid is not round in the anterior part. He has a fragment that was a fracture, a glenoid fracture that was healed medially. And here we have the humerus. I have just 3D printed this in ABS. It has some supports, as you can see. It's not cleaned, but I'm going to start. Here we can see the Hill-Sachs lesion right here. It's very medial, very proximal to the head. And now we are going to plan a Latarjet procedure. And we are going to show you every step we need to plan any surgery, actually any orthopedic surgery. Let's do this is small. First of all, we are going to open his CT scan. As we can see here, this is the CT scan. Let's open the, here we can see, so we have all the slices, okay? And I'm going to show you how it's easy to transform the CT scan into a 3D file. Here in the CT, we can already see the bunkered lesion. As you can see here, we can see that it has a cartilage lesion as well, and we can also see the Hill-Sachs lesion here in the posterior part. So let's open. And to make a 3D file is very simple. I'm using the Horus software, as you can see here. It's an open source free software. It's only for Mac, but there are many softwares available for Windows. One of them is Invesalhos, and one of them is Instant Meshes. They are pretty much the same. We click here and create the 3D surface rendering. I'm going to choose 250, hit OK, and the software will select every slice and make a 3D file from here. So it's done. We can see here that is everything is here in our screen. We can see here the file. And now we are going to export this file into a STL file. Once that's done, let's click here. It's not important anymore. Okay, I'm going to use a regular CAD software. Okay, here I'm using the Rhino software, Rhinoceros. It's a regular CAD software. I have just imported file import. So we will import the file. I imported the scapula file of him. And here I have already imported. This is a guide I have created, as you can see here. Okay. I'm having some trouble with the sharing screen. Let's check what's not working. Let's remove here. Okay, I'm having some trouble. I'm going to open Hangouts and see if we can change for the application window. No, still having problems. Well, this is live. Entire screen. Let's reopen. Oh, sorry. Let's reopen the RhinoCAD software. So we are going to show how we can 3D plan our surgeries, how we can do actually any surgery, an osteotomy, plan a reverse total shoulder, a regular total shoulder, any surgery we can plan using just a regular software. There are some softwares in the market that are especially created for that. They are especially created for orthopedic surgery, but they use some materials. Some of them are linked to some companies. So with this regular software, we are open to do everything we want. We are open even to plan a Latarjet procedure that uses only screws. So I think we are okay. So I have just imported the scapula file, and this is the guide for the coracoid. I'm going to show you first here. This is another example. This is not the patient we are choosing. This is another patient that has an anterior defect. As you can see, a very significant bunkered lesion, and we have designed this guide. Okay, it's like a grasper that has, oh, okay, let's reopen, no problem. So let's start. That grasps the coracoid and show us where to drill the 2 screws. It's from lateral to medial. I think you can see right now. So this guide we're going to develop. Okay, it grasps the coracoid, shows where to drill, and these 2 drills will be the parallel screws. We're going to fix on the medial part, the anterior medial part of the glenoid. Okay, this guide is already designed, so we're going to plan where we are going to place the screws here first in the coracoid, and then where the coracoid will be placed on the glenoid, and then we're going to create a guide to help us place the screws even on the glenoid. Let's see if we can make this work. Okay, first of all, we start aligning the scapula. The coracoid it's a very twisted bone. It's difficult to understand exactly where its location. As you can see here, this would be almost like the front view. So it has it's twisted like this way. So we move until we have a good view first from the coracoid, and now we are going to plan our surgery. We need to place this guide into the coracoid. Okay, I'm going to first show you how I do before placing the guide. We are going to create here a cylinder that is just like the screw, or it's the guide for the screw. So let's place the cylinder here just above the coracoid. We can check right here in the corner, okay, the size of the screw, but let's do, this is not the actual screw. We're going just to place a reference. So here and here, now we have one screw, and now we are going to place it in the right where we would like to have our distal screw placed. And here is the key. It's difficult to place, to really understand which how is the coracoid, how the screws will be parallel to each other, and which the best fitting position. As you can see here, is this way, is that way. Sometimes I'm not that sure, but I think the way I done is almost okay. So here we have one screw. Let's place a little bit distally because I think we won't have many space. I think it's okay. Let's just Control C, Command C, and Command V, and create another screw. This would be the place for the two screws. We have some space for the osteotomy here. We can place a little bit more like that. There is no problem. So now we have the direction we want. The screws are parallel to each other. And now we are going to place our guide just above the coracoid. Let's move this way. Oh, first, let me show you the parts of the guide. It's difficult to understand, but here's the grasper. Let's change for the perspective view. I think it's easier. So we have here the one part of the grasper, the superior part, the inferior part. Here are these two cylinders, are the two cylinders that will match. These two cylinders is where the screw will pass through. This is just this, okay? So we have this these bigger cylinders that they are guides for the drill, and we have the smaller cylinders that are the drill itself. We're going to remove, okay? And we have here, we have this plane, as you can see here, and plane, as you can see here, they are just marks for me. This plane is the center of the guide, and this is the how can I say, this is the distal part, actually the medial part of the guide. So the coracoid should be placed here, and this is where the osteotomy would be done. So this is our references for me. Okay, let's change our perspective and let's move the guide to the coracoid. As we can see here, the guide it's not parallel. I think it's okay. Let's see here. Let's move a little bit. It seems okay. Okay, let's move here. Let's move over the screws. Let's take a look. Okay, I think they are almost intersecting each other. As you can see, those two screws, those two blue screws, were covered by our guide. I think I was my view was okay. This guide is not in the center. Let's move up a little bit. I think that would be nice. So we can see here, okay, we can have space for the osteotomy, although it would be needed a very posterior osteotomy, but that's what we need. There is no way to place this more anterior or in the distal part of the coracoid or an anterior part of the coracoid. I think this is okay. Okay. Now let's do, now we have the guide. Okay, the guide are okay. Let's create now the guide for the osteotomy, or we can do something different. I'm going to first do the surgery itself. So, okay, now we have the guide. We know where the guide will be. Let's remove this guide from here. And now we have the coracoid. Okay, we are going to perform the osteotomy. We know these two screws are okay, they are in the correct position. Then we are going to create a guide for that. But now we're going to perform the surgery. So we have to perform a osteotomy. So I'm going to draw a box. It's more like the oscillating saw. It's like a plan, as you can see here. I'm going to create a plan just like that. It's not big, not needed to be very huge. And this is the plan where we are going to do our osteotomy. As you can see here, it's not okay right here. We should move anteriorly until we think this is a good osteotomy. I really think this is osteotomy we can perform. Okay, we have a good piece of the coracoid, not too posterior. So now we are going to do the osteotomy itself. So we are going to select our object. This object is called mesh, okay? And we are going to create here mesh split. Now we want to select the splitting object. The splitting object is this blue plane like here, and we are hit enter. And that's okay. Let's see if it was, oh no, we are not success. I think it's not splitted. Let's do it again. Edit, let's do the trim. So let's select here. No, it was not select trim. No. Let's do again. This happens. Mesh. Mesh split. The splitting object. Hit done. Let's see if it was splitted. It seems it was splitted. Let's check. We are going to select mesh, edit, and extract part. Now we are going to select the part we want to extract. Hit done. Okay, it was selected. Then enter. Okay. Now we have a coracoid, as you can see here. We are going to delete this plan. Now we have here the coracoid, the osteotomy. Just select it. I'm going to select the coracoid and select the two screws we are going to use, just like this. And now I'm going to group them. Group, Command G. Now this group is just one object. Okay, now let's perform the Latarjet surgery itself. Let's position our glenoid in a better position for us, like just as the surgery. So let's move it like that. This is not entirely necessary, but I think it helps a lot to place the glenoid parallel to us. As you can see here, let's move like this. And I think we have a good view. We have the front view. Let's rotate a little bit to have a more front view. I think it's okay. I think here it's okay. And we have here all the views. We already have the coracoid here that has the osteotomy, as you can see here. Okay, this is the coracoid. Let's move it to the anterior medial part of the glenoid. Just let's rotate like that. I'm already looking for the position I'm going to place it. Let's place in position. Let's look here. I think we could place it a little more inferiorly, like that, in the inferior part. We could rotate a little bit to have more bone. We could up a little bit, and now we can check where we want the coracoid, if we want it more lateral or more medial. Okay, I'm going to do just like that, and I'm going to look for the perspective view, as we can see here on the perspective view. So we have a glenoid defect, as we can see. On the surgery, during the surgery, I think we were going to remove this part of the fracture, yes. So the coracoid will be placed more inside the bone. So let's position it a little bit more inside the bone. This part, of course, it's more like that. Let's see. It's not lateral enough. I'm not that sure if it's too medial, but I think it's okay, because here we don't want the coracoid to be just in the articular side. We would like to be at where it should be. So I think it's okay. They are parallel to each other. If we want, we can rotate a little bit, because sometimes this superior part of the coracoid seems to be more articular. As you can see here, sometimes I check this, that the superior part seems to be more articular, you know. So sometimes I like to rotate a little bit like that. Okay, so they are more like parallel to each other. We can now move a little bit medially. It's not articular. We can see the screws are parallel to each other. We can see where the screws will live on the glenoid. It's a very good position. They are very parallel to each other. They are very parallel to the glenoid. I really think this is a good position. We could put a little bit more down, but I think it's okay. It's in the inferior part of the glenoid. I'm okay with that. I'm very okay with that, actually. I'm going to save. Now that's important. I'm going to duplicate this file. You're going to understand actually why. Okay, let's plan. I'm going to change the name. Lucas plan glenoid. So we're going to use this to plan the glenoid. Okay, now we want. And here, something that it's important, going to go back to the original position. So let's hit Ctrl Z, Command Z, or Edit, Undo, okay, until we have the screws in the correct position of the glenoid, because we're going to use this relation Coracoid gap to duplicate file to Coracoid planning. Okay, but let's go back to the glenoid. Okay, here we have the glenoid. Just let's check if our okay. That's okay. So let's continue with our planning. Okay, let's open here. So here we know where the coracoid are. I'm going to delete the coracoid. Okay, the coracoid doesn't matters anymore. Is where to place screws. Okay, so we could do something like we could 3D print this. This is something I generally do. I 3D print with the screws where I want the screws. So if my guide doesn't work very well, I can look during the surgery, know where are the screw, and actually, and the most important part is not actually where the screw, but the direction of the screw. So we could 3D print just this part. This is something I think it's very important to 3D print the glenoid with the location of the screw. We're going to do this, and we can now create, for example, guides. Let's create a PSI guide, a patient-specific guide. It's very simple. Let's change colors here. I'm going to create a very simple guide. Let's draw a box. The glenoid, not very big box. Okay, let's change. I'm going to do a very simple guide. Too big. Okay, let's put here the box. I'm going to be a larger on the articular side. So here we can see the box. Okay, the approach for the coracoid is very small, so we shouldn't have big guides. I'm going to do a smaller one, just like that. And it's a very simple guide. Generally, I do more sophisticated guides with handles, and we're going to show you later. But I'm going to show how to make a very simple guide showing where to place our screws. Let's select our box, mesh, Boolean operation, difference. Let's select the glenoid, hit enter, nothing happened. So we might have some problems with the mesh. Sometimes the mesh, they are so the triangles, they don't intersect very well. Let's try to do again Boolean operations, difference, not again. Okay, that's something that's important. Let's reduce our mesh, reduce in 50%, a little bit more fast. Okay, let's make sure if this works. This is very common difference. No, not working. I'm not being successful tonight. Let's try again, mesh. Let's repair this mesh, edit, rebuild mesh normals. Okay, mesh, Boolean. Let's difference the screws first. Okay, now we have the screws, as you can see here. Let's check if we can do with the glenoid now. No, I'm not being successful. That happens. That's actually not that uncommon to happen. The first days I had more problems because the mesh, the file was not very well created. I'm recently having fewer problems, but sometimes just like that, or just like today, we are having problems. Let's change our, let's do again. Okay, a box. Let's move the box just like this. I'm not going to be worried about the angle. And let's check if it's going to work. No, not again. Okay. Now I'm embarrassed. I'm life embarrassed. But this would be the tool we are going to use in any regular software. Okay. Let's check if we change for a sphere. Something like a sphere would work best for us. Like this, like this, like this. Okay, just like do it like that. Let's check if this sphere would work for us. Mesh, Boolean, difference. No, it didn't work. Okay. When this happened, okay, is because we have problems with the mesh, with this file, okay? So sometimes we have to redo it again. That's important. We are going to try to repair. I'm going to try to repair the mesh. Unify normals, mesh, that reduce the mesh again in 50%. Okay, let's check if we could right now. No, we're still having problems. Okay, mesh, Boolean, difference, still having problems. Okay, let's try to do fill hole, fill all holes. Okay, mesh, edit tools, repair, mesh normals. Let's try again. A box right here. I'm not worried right now about the size actually of the box. I'm just trying to make it work right now. Difference. Okay, it's almost like willing to work. Let's try again. Let's select everything together and let's check if it worked. No, but we are getting there. We are getting there. We are going to do this. Let's do like that, Mesh, Boolean, difference. Here, here, and here. Nope, that's not okay. Sometimes smaller parts work better. Oh, difference. We can do like that. And let's try again like that. Mesh, Boolean, difference. No, not working. So that when that happens, we must do everything again. So we must re-import the CT scan and place over here because we probably having problems. As you can see, these are very small triangles. Sometimes it's not. It's very small that they are not very connected, linked, and this problem happens. Okay, let's try if you can do this with the Coracoid. As we are here, let's do a very easy, very quick Okay, let's check. Mesh, Boolean, difference. Let's check if it's going to work with the Coracoid. With the Coracoid, is not working as well. So with problem, the file has some problems. Difference. Yes, we're still having problems. Let me open another patient. How we did. Let's open G. Here we have. Okay. Planning. Let's open this file. This is for another patient. Okay. So here we have the Latarjet, the glenoid position. Okay. The guide. Let's hope this works. Let's delete the Coracoid. Here we have the 2 screws we want. Okay. I'm going to draw a box right over here, right over here. Let's place the box that way. Let's place the box that way. We need a bigger box like that. So it's okay. I think it's bigger than we need, but let's try if it's going to work. Oh, sorry. Okay. The box is worked. Let's do the same with the screws here. Let's do again. Mesh, Boolean. Okay. And now here we have the guide. As you can see here, the guide. This guide adapts to the anterior medial part of the glenoid and show exactly where to drill. We could do a better guide, doing like the Coracoid procedure. We could create another cylinder here to be external guide, but I think it worked very well this time. And for the Coracoid, it's the same. I'm going to this presentation. Let's open the Coracoid. Here you can see how the guide is already done. Okay, so here fits the Coracoid. The guide is done, and then we 3D print them. Let's open if we have here a best guide. So here we saw there. Here we have the Coracoid guide positioned, and we just hit as we did. Difference, hit the glenoid, and the guide is created. Now we should create the holes like that. Difference. Let's select this one. These 2 extrusions, this group, this extrusion. Okay. Mesh, Boolean, difference. Okay. Okay. Now it's done. We can just delete everything. And now we have the guide. As you can see here, this is actually the guide just like this. As you can see here, I'm going to move down a little bit. This is just the guide we have created. This is actually for this patient, actually. Okay. So it's just we're just going to 3D print these guides and perform the surgery. Thank you very much. I'm sorry for that not working. Sometimes we need to work on the 3D file for the problem we have, I suggest open the Mesh Mixer software, as I'm going to show. I should did this before. I was assured the file was okay, but of course it wasn't okay. That's my suggestion. Import that file, that glenoid file that didn't work live. One of the problems should be because we are broadcasting, so my computer is it's heavy. So sometimes this is a very heavy operation. Sometimes maybe should be by this, but if that doesn't happen, we should do this inspector tool, and sometimes I suggest doing just like this. This is the make solid operation. Okay, this makes a more smoother part, as you can see here. One thing that I could do this before, because during surgery we are going to have this fragment. Okay, I think this fragment is important as reference where to place our screws, but we're going to remove it to place the coracoid, so we can actually remove before surgery. Let's select here. Let's do like this, just as Photoshop. Hit delete, and now we do the make solid again. Accept, and now we have the removed. If we don't like these bumps like here, we can sculpt a little bit like that, as you can see, just as we would do on surgery, you know. So what I would do, I would export this file again and reopen on the CAD software to plan the surgery all over again. Thank you very much. I'm going to post on LinkedIn and Twitter our 3D files after we done this all over again. Questions, just ask me, and bye-bye.